absolute value is the distance from 0. When we graph this, there are dots that have a distance of 4. If you're equaling, you're going to have solutions. So on the left side, I'm just going to focus on the left equation. I would first add 3 on both sides, and I'm going to get is equal to 7. On the right hand side, I'm going to isolate x, so I want to move everything that's with x. I'm going to move the -3 to the other side by adding 3, and x equals -1. So you can see here that there are actually 2 different answers, and I'm going to show you why. Okay, so I want you to look on those numbers on the number line, and to you right now, even to me, it doesn't look like they have a distance of 4 from 0, right? They don't have a distance of 4 from 0. You can see here that in the original equation it says x minus 3, which means that after you subtract 3 from this number, then it will have a distance of 4. So if we look at our first number of 7, I'm going to subtract 3 by going 3 to the left, and now it has a distance of 4 from 0. So the distance is 4 from 0. I'm going to do the same thing for -1. I'm going to subtract 3, and you can see here it moves 3 to the right, and now I have a distance of 4 from 0. So both of these numbers, after you subtract 3, will have a distance of 4 from 0. That's what the question is asking us. Question, Josh.
Like if I were to do the question, can I use like the number 7 or do I use 3?
So you don't always have to be 3. So as an example, if it was x plus 1 is equal to 4, then it would be saying, well, if you add 1 to a number, what would have a distance of 4 from 0?
Wait, so it always have, so both of them have to have a distance of 4?
No. It could be 7.
I don't really get it.
So we'll work through some more examples. Okay. Here, I'll change the number. Well, I'll do these examples first, and then we'll talk about it. Okay. So this one, when it says the absolute value of x minus 3 is equal to -4, what it is saying is that the distance is -4, which does not make sense. Thank you, Jason, for donating your phone.
How'd you see me?
Okay, so what I want you to know is that you can't actually have a negative distance. So if you equal a negative number, then there is no solution. So anytime you are given that an absolute value is equal to a negative number, there is no solution. There is no solution.
Wait, what?
So anytime you take an absolute value of a number and it equals a negative number, there is no solution. Okay. Our last example for equalities is that you might have something, and again, this is all detailed in your notes in words. I'm just giving you examples. These are the 3 different examples you guys just wrote down. But maybe you learn better by looking at these examples. The third example is that x minus 3 is equal to 0. And in this case, we're only going to have one solution. We're only going to have one solution. So in this case, you would get rid of the absolute value, and it would be x minus 3 is equal to 0. We would plus 3 on both sides, and we get x equals 3. Normally, you might think, oh, maybe it equals plus or minus 3. And I want you to think about this. So they're asking us, when I subtract 3 from this number, it's going to have a distance of 0. So if I take 3 and I subtract 3, it's going to go 3 in this direction and then equal 0. If I were to do the same thing to negative 3, it would actually get more, and you can see it would now have a distance equals 0. 0, it actually only, okay, so that's something I want you to remember. And if, or reason out that if you equal a 0, you'll only have one solution if it's an absolute value. Joshua, you had a question.
So, never mind, I didn't know.
Okay, so all of this is about what is the distance from 0 on the number line. Okay, and so when you equal something, you can see here, this is all it's saying is that is the distance away from 0, and this is saying what happens if I subtract a number, if I add a number, and eventually we'll get into if you multiply or divide by a number. Again, you don't necessarily have to reason it out, but I want you to understand this is the math, this is what it's talking about, right? It's not just random things. Okay, it gets a little more complicated. So all we've been doing so far is a culmination of everything we've been learning, right? All of these things have been leading up to this point. So our fourth example is now dealing with inequalities. Our fourth example is now dealing with inequalities. So here we have a very simple example. What it's saying is that the absolute value of x is to 8. Okay, so all it's saying here is that the absolute value of x is greater than or equal to 8. What that means here is that the distance away from 0 is equal to 8 or greater than 8. Right? The distance away from 0 is either equal to 8 or greater. So I want you to think about what numbers have a distance away from 0 that is 8 or greater. What are some numbers?
So I have a question. So in this case, it can't be like 6 or 5 or anything?
Can't be 6 or 5. That's a good deduction. So what could it be?
9.
9? 10? Haley? That's fine. What else could we have? 11? What else? What about negative numbers? We can't, because negative 8 has a distance of 8 away from 0, right? So you can actually go more in the negative direction. So something I want you to note is that you can have x is greater than or equal to 8, or, and I want you to think about it, is negative 6 closer to 0, or is negative 9 closer to 0? Which one is farther or closer to 0? So which one's closer to 0? Right, negative 6, right? The smaller the number, the smaller the negative, the closer it is to 0. So you can see here that what we want a distance of 8 or greater, so we want the numbers to be even smaller than negative 8, right? So that means x is also going to be less than or equal to -8. So one thing you want to note here is that when you have a negative number, so when you split the inequality into the two inequalities, you're actually going to flip the sign when you equal the negative number. Okay? So when, for inequalities, when you let it like equal the negative version, it's actually going to flip the sign, right? And this is the same rule that when you add or when you multiply or divide by a negative number, you're going to flip the inequality sign. Question?
Do we have to make the underline?
No. That has just helped you visualize what is going on here. This question was, do we need the number line? No, but I find it helpful for you to see what's going on there.
So on the test, like, you don't have to know.
No.
So on the test, you just do what you do with it.
Yes. Okay. Okay, so I'm going to solve a more complicated problem, and I want you to see what I'm doing here. I'm going to solve two problems. Okay. And then that'll be it. And then you guys can work. Okay. Okay, so our first example is right here. Okay, so the first thing that we could do is we can split this into its two different equations, but before then, what do we see outside of the absolute value? What do we see outside the absolute value? All right, sorry, we're just looking at the top one. We see a number. What number do we see? The 3. So what it's saying is that 3 times a number is less than or equal to 6. So the very first thing we can do is that instead of multiplying everything, I actually want to get rid of that 3. So an easy way is to just divide everything by 3. Just to be careful, make sure that if there is a negative number on the outside, you also flip the sign. So I'm going to actually write it over here to give myself more space. And we get the absolute value of x minus 3 is less than or equal to 2. Okay. I can split this into its two different inequalities. One is that x minus 3 is less than 2, or x minus 3 is greater than or equal to negative 2.
How did you get the 6 over 3?
So you can see that my original equation was this, right? This is original inequality. Then what I did is I wanted to get rid of the 3 on the hand side, so I divided both sides by 3. And then you can see that so it looks like any more? Okay, if not, we're going to move on to our final example. Right? Fraction multiple multiplied by 4, which is just if I want to get rid of the 4, way is to just multiply by that same number. So I'm going to multiply the left hand side by that number, and I'm going to multiply the right hand side by that number. What that does is it gets rid of this 4 on the bottom, and so these just cancel out, and I don't need to do anything to the inside of the absolute value. I keep it the same, and I get the absolute value of x minus 4 is greater than or equal to positive 12. Okay, so at this point, this should come pretty regular now. We're going to split this into two different equations, or inequalities, sorry. X minus 4 is greater than or equal to 12, and then x minus 4 is less than or equal to negative 12. Just as a reminder that I'm flipping the sign here because this becomes a negative. So just like the same rule that when you multiply by a negative number, you have to flip the sign. When you divide by a negative number, you also have to flip the sign. So I'm going to go ahead and solve this. What I would do on the left-hand side is I would add 4 to both sides, and I would get x is greater than or equal to 16. And then I'm going to focus on the right equation. I'm going to add 4 to both sides. X is less than or equal to negative 8. Okay, so at this point, I want to think about, can my number be greater than 16 and equal to 16 and also less than negative 8? Can my number be less than negative 8 but also greater than 16? So if I look on the number line, it's going to look something like this. If my number is greater than 16, it's going to be, and again, I would bubble it in for this one. It would be in this direction. If it's less than negative 8, it would be negative 8 would be down here below 0, and it would be in this direction. So do these sections overlap? If they don't, then this is going to be an OR statement. If they do not overlap, it's going to be an OR statement. Okay, that's it. You're done. Okay, so for this, those would be your answers.
So you don't have to number line it. You don't have to number.
You don't need the number line, but again, if it helps you to visualize if you need an or an and, I would draw the number line. Oh, sorry, I didn't mean to disconnect.